Hello everyone, I am Shankar, faculty for Power Electronics and Control Systems at OHM Institute, Hyderabad. In this video series, we will discuss the previous year gate questions from Power Electronics subject. And before starting into this video, I would like to give you some reference textbooks and what all the material you need to refer. As per my knowledge, I am in this gate coaching since 2008. As per my knowledge, the best book to start power electronics subject is Power Electronics by P.S. Bimra. It is a very good book for beginner, but by analyzing the previous year gate questions since last 5 to 7 years, I noticed that some questions from gate exam are a little bit beyond this book level. Therefore, I will suggest the second reference, Power Electronics Converters, Applications and Design by Nedmohan book. But for the beginner, this is a little difficult to understand. With the help of any good faculty, you can study this book. And the third reference is Power Electronics by Muhammad Rashid. This is also good book. So, instead of referring various books available in the market, as per my experience, these three books are more than sufficient for gate exam. Next, coming to during the preparation side, what type of material you can refer? You can refer OHM Institute classroom notes and handouts. At OHM Institute, we will give detailed explanations in the class, whether it is offline class or online class, and at the end of the class, we used to distribute handouts. These handouts consisting of very standard questions for practice. Of course, you can refer previous gate PYQs. The objective of this video is also to solve all the previous year questions in detailed manner. Of course, whether you are up to the mark or not, you can test your knowledge by attempting some test series. So, we are conducting here online test series as well as offline test series. Offline test series means once the class is completed, we will conduct on a particular topic these tests and all. So, now without wasting our time, we will jump on to the video. So, the total syllabus I divided into various chapters. In this video, I am discussing the previous year gate questions from first chapter, that is basics of power semiconductor device, and this particular chapter I divided into two parts. In the first part, we will discuss what all the concepts that are came from previous year's gate. I arranged in a particular order, the conceptual order. Of course, 1 mark and 2 marks questions are mixed, these questions will come randomly, but the point is all questions will discuss in a concept wise. Now, in this question, let us see here, a MOSFET is rated for 15 ampere, carries a periodic current as shown in the figure. So, some current waveform is given here, its a peak value is a 10 ampere, even though MOSFET is expected to carry for 15 ampere, but depends on the application, it is carrying just 10 ampere. The on resistance of the MOSFET is 0.15 ohm. Now, we need to calculate average on state loss in the MOSFET. So, as a MOSFET during the conduction state, it is modeled as a resistor. We can express the conduction loss in the MOSFET with IRMS square multiplied with on resistance. So, how to express this RMS current? So, IRMS square is equal to, because the waveform is given as a square waveform, you can write down the RMS value as magnitude square into function duration, that is pi, divided by 1 full cycle. Okay. Therefore, it will be simplified as pi can be cancelled and then this value is equal to 10 square divided by 2. Now, by substituting this RMS square, we can get power loss, conduction power loss is equal to 10 square divided by 2 multiplied with on resistance is given as 0.15 ohm. Therefore, 100 into 0.15 will give you 150 divided by 2. I am sorry. So, here 15 divided by 2, this will give you 7.5 ohm, and hence the answer is C is the correct answer. This question is given in GATE 2004 for 2 marks. Now, the next question, the voltage across and current through a semiconductor switch during turn on transition are shown in the figure. The energy dissipated during the turn on transition in millijoule is. So, in this case we can find out energy loss during 2 intervals, one is a T1, another is T2. Therefore, say for example, if I take here T is equal to 0, so that this point I can say upper limit will be T1. Therefore, energy loss during first interval, let us call it E1, it can be written as integration from 0 to T1 voltage across the switch multiplied with current flowing through the switch, Vs multiplied with Is. Now, here in this interval we can closely observe that voltage is constant, that is 600 volt. If I take that 600 volt outside, then the remaining integration will be integration from 0 to T1 Is dt. So, this integration we can say that this particular integration we can say that area under this particular current triangle. So, how can you simplify this one? 600 multiplied with area of the current triangle, that is 1 by 2 multiplied with height of the triangle is 150 and base of the triangle is 1 microsecond, that is 10 power minus 6. Then if you simplify this, we will get 45 millijoule. Therefore, there is a loss of 45 millijoule during interval 1. Next, in the similar way, the energy loss during interval 2, it can be expressed as integration from 0 to T2. Now, what I will do here, during T2 interval I will take this point as 0 and this point will be T2. So, integration from 0 to T2, same integration Vs multiplied with Is dt. So, in this interval we can closely observe that current value is a constant. Therefore, if I take this current value is outside, that is 100 multiplied with integration from 0 to T1 voltage, that is Vs dt, right. Therefore, the value of this integration we can say this is a area under voltage waveform. So, now we can simplify as 100 multiplied with area of that voltage triangle, that is 1 by 2 into 600 multiplied with base 10 power minus 6. So, this will give you 30 millijoule. So, the total energy loss during this transition is equal to energy loss during interval 1 plus energy loss during interval 2. By adding this 45 and 30, we will get the answer 75 millijoule. Therefore, answer for this question will be 75 millijoule. Now, let us move to the next question. This question is given in GATE 2005 for 2 marks. The following figure shows the voltage across a power semiconductor device and the current through the device during a switching transition. Is the transition a turn on or turn off transition? Now, we can observe here during this transition what is happened, voltage waveform is falling and current waveform is rising. Okay. Therefore, voltage is falling and current is rising. Okay. So, this transition will be turn on transition. Whenever a power semiconductor device is turning on, current will slowly increases and voltage will decreases. Okay, that is first part of the question. Now, what is the energy lost during this transition? So, as in the previous question, here also the energy loss can be calculated as during T1 interval voltage is constant, therefore, voltage multiplied with area of this current triangle. Similarly, during T2 interval current is constant and voltage is varying. Therefore, energy loss during this turn on transition is voltage multiplied with area of current triangle, that is 1 by 2 into T1 into I plus, now during T2 interval current is constant, therefore, I multiplied with area of the voltage triangle. So, half into V into T2. So, if you take Vi upon 2 common, it will give you T1 plus T2. So, this is the energy loss during turn on transition. Therefore, for this question the correct answer is the transition is turn on transition and Vi by 2 into T1 plus T2. Option A is the correct answer. Now, let us move to the next question. This question was given in 2016 GATE exam for 1 mark. A steady DC current of 100 ampere is flowing through a power module, that is given as S and D. S is a IGBT section and D is a diode section as shown in the figure A. So, this is a arrangement. Now, the IV characteristics of individual IGBT module and diode module are given here. So, we need to find out what is the conduction power loss. This is the question. What is the conduction power loss? Now, for this particular case 100 ampere is given that it is flowing in this direction. Therefore, this 100 ampere current will flow through this diode module. Okay. Therefore, we just need to look into the diode characteristics only. Of course, additional data is given, we need not to consider that IGBT data. So, what is that power loss formula? How to express this? When the steady DC current is flowing that, then what it is mean, average value and RMS value both are same. So, I can write it like this: average current is equal to RMS current. So, both are equals to 100 ampere. What is the reason for this? In the question it is mentioned, it is a steady DC current. Okay. Now, from this characteristic there are 2 important points. One is voltage drop across the device, that is a 0.7 volt, and this particular parameter you can say it is on resistance of the diode, on resistance of the diode. Therefore, the conduction loss in the module you can express it as voltage across the diode, let me call it Vt, multiplied with I average plus R on multiplied with I RMS square. Therefore, if you substitute this data 0.7 into I average is 100 plus 0.01 into IRMS 100 square. So, this value if you evaluate, you will get 170 watt. So, this is the answer. Therefore, answer for the question is 170. Now, let us move to the next question. This question was given in GATE 2070 for 1 mark. For the power semiconductor devices, IGBT, MOSFET, diode and thyristor, which one of the following statements is true? Now, just by going through all these statements, what we need to identify that which device is a majority carrier device and which device is a minority carrier device. So, let me write down quickly about this classification. Say for example, if you take majority carrier devices, okay. So, this is basically a MOSFET, majority carrier device, basically it is a MOSFET. Whereas, coming to minority carrier devices, what all the devices that comes under minority carrier devices? Power diode, power BJT, SCR, GTO and triac, basically thyristor family devices. All of these devices will come under minority carrier devices. But here the ambiguity is with IGBT. So, what is basically IGBT? IGBT is a voltage control device, but that is the device developed by modifying MOSFET. The construction of the MOSFET is a little bit modified in order to design this IGBT device. Now, what is that modification? MOSFET is majority carrier device, in that by introducing the minority carrier injection, IGBT device was developed. Therefore, MOSFET is a majority carrier device, whereas IGBT, diode and thyristor are considered as minority carrier devices. Therefore, for this question the correct answer is D. Now, let us look into the next question. This question was given in GATE 2003 for 1 mark. So, here a MOSFET figure is shown with an integral body diode. It is employed as a power switching device in the on and off states through appropriate control. The on and off states of the switch are given on V and I plane. Now, we just need to identify what is the correct one. So, whatever the device given here, this device belongs to unipolar and bidirectional switch, unipolar and bidirectional switch. Therefore, from these given options, unipolar, because of that internal body diode, it will be bidirectional, current can flow in both the directions. So, again unipolar means it will block the positive voltage. What is that positive voltage meaning? When the drain terminal is more positive than source terminal, the switch will behave like a turn off switch. Therefore, for this question option B is the correct answer. Now, let us go to the next question. This question was given in GATE 2010 for 1 mark. The following figure shows a composite switch, that switch consisting of a power transistor, that is BJT, in series with a diode. Assume that the transistor switch and the diode are ideal devices. Now, what is the IV characteristics of this composite switch? So, for example, if I give positive terminal here, then what happens? This transistor will block positive voltage. Say for example, let me take, this is a terminal A and B. Across the terminal A and B, the switch the transistor will block that positive voltage. Therefore, it will be positive side blocking. When the polarities are interchanged between A and B, then what happens? A diode will be blocking that voltage. Okay. Therefore, this particular combination will block both sides of the polarity. Okay. So, for example, if I draw, this is a V and this is a I. So, this particular voltage can be positive voltage blocking and negative voltage blocking, and the overall switch combination will carry the current from A to B only. B to A, this current cannot carry. Therefore, the answer should be bipolar and unidirectional switch. So, the characteristics should be, here it should be something like this. So, this is how the answer will be. Okay. So, with this the correct answer will be this option C. Basically, it is a bipolar and unidirectional switch. Let us go to the next question. This question was given in GATE 2014 for 1 mark. The following figure shows 4 electronic switches named as 1 to 4. Which of these switches can block voltage of either polarity? Voltage of either polarity means bipolar blocking. The switch should be bipolar blocking. Okay. And which of the switches block voltages of either polarities? When the active devices is in the off state. So, as per my knowledge, some statement is missing. A current should be carrying in one direction. Okay. Current in one direction. Okay. Therefore, so we need unidirectional switch. We need unidirectional switch, right. So, as per this particular configurations, SCR will be bipolar and unidirectional switch. It can carry the current in one direction. And in the previous problem, we learned that transistor device will be in series with the diode will also behave like SCR. Therefore, these two options will be correct ones. So, what is that? One option is SCR, another option is the transistor device in series with the diode. Now, of course, it is not in the scope of the question. Suppose if you look into option 1 and option 4, these are unipolar and bidirectional switch. Unipolar and bidirectional switch. Okay. So, this is so for this question answers are 1 and 2. Now, let us look into this question, GATE 2018 1 mark question. 4 power semiconductor devices are given in this figure. Now, the devices that can carry current continuously in the direction shown when gated approximately. Okay. So, here the current is given like this. Now, in this case, GTO and thyristor, they cannot carry the current from cathode to anode. Okay. So, these two are not the correct answers. Triac is a device that can carry the current in both the directions. Okay. Next, coming to this, this MOSFET is N channel depletion MOSFET. This is N channel depletion MOSFET. So, the basic reference direction for the current from, it can carry the current from drain to source. Therefore, for this question the answer will be triac. Now, let us look into this question. This question asked in GATE 2005, 2 marks. An electronic switch S is required to block voltage of either polarity during its off state as shown in figure A. That means we need here bipolar feature. How can I identify that? The switch is required to block voltage of either polarity, either positive or negative. Next one. The switch is required to conduct in only one direction. So, that is from one terminal to one dash terminal. So, we need unidirectional switch. So, from this given options or given figures, we just need to identify bipolar and unidirectional switch. So, for this first option, if you draw V and I characteristics, SCR is a device that can have both forward blocking as well as reverse blocking, and it can carry the current in only one direction. Therefore, option 1 is correct. This is this device is suitable for the given option. Now, coming to this transistor is in parallel, in anti-parallel with diode. Therefore, in this case what happens, this particular device voltage can block this one, this transistor device can block voltage of one polarity and it will carry the current in one direction. Up to transistor it is unipolar and unidirectional device. The moment when we connect a diode in anti-parallel, what it can do, it can block, or sorry, it can carry the current in the reverse direction as well. Therefore, this particular device can carry the current in both the directions, okay, unipolar and bidirectional. Therefore, this device is not required for our question. Coming to this transistor in series with diode, this one we discussed in the previous problem also. By this time you might understand there are several questions in the previous GATE papers only on this switch classification. Okay, switch classification is very, very important for GATE exam. Now, this is a bipolar and unidirectional switch. So, we can select this is also one option. Now, if you see this third option, BJT, power BJT with a series diode is equivalently similar to SCR characteristics, bipolar and unidirectional switch. So, when a diode is connected in anti-parallel to this this combination, if you observe carefully here, this particular part is similar to third option, right? That means SCR. For SCR there is an anti-parallel diode. Therefore, what we can say here, this particular device will simply behave as unipolar and bidirectional switch. Okay. Strictly speaking, SCR will block voltage of both the polarities. Whenever the diode is connected in anti-parallel, it will miss that feature and it will get a new feature called current will flow in a reverse direction. Therefore, correct answer for this question is 1 and 3 options. Now, there is another question on these switches. This question asked in GATE 2009 for 2 marks. match the switch arrangement on the top row to be a steady state IV characteristics on the lower row. Of course, just a space adjustment, I arranged, see this is a top row and this is a lower row. The steady state operating points are shown by large dots. Now, we just need to match these things. So, here diode can block positive voltage, that is that is a negative voltage between anode and cathode during its off state. It will carry the current from anode to cathode, that can be treated as a positive current. Therefore, here I can take fourth option, right, this one, or I can write A here. So, during off state it can block negative voltage, during on state it can carry positive current. Now, SCR, it can block both voltage of positive as well as negative, and it will carry the current from anode to cathode, that will be treated as a unidirectional switch. So, it can be matched with third option. So, this is a, it can be matched with the B. Next, IGBT without anti-parallel diode. So, it can have positive voltage blocking like this, and it will carry the current in one direction. Okay. So, this is a unipolar and unidirectional switch. Now, IGBT with anti-parallel diode is given, so it can block positive voltage and it can carry the current in both the directions. Therefore, it can be matched with option 2. So, this is D. So, that is the matching question. Now, let us look into a very recent question. A semiconductor switch needs to block voltage V of only one polarity during off state. So, what do you mean by that statement? We need to select a switch that is having unipolar voltage blocking property okay, and it needs to carry the current in both the directions during on state as shown in figure 2. That means bidirectional switch is required. So, from these given 4 options, of course, this question is MSD, I forgot to mention here, MSQ, multiple select answers. So, this has more than one answer is correct. Now, we just need to identify what switch will have this feature, both unipolar as well as bidirectional. Now, a transistor with anti-parallel diode, what type of characteristics it will have? It can have voltage blocking one polarity and it can carry the current in both the directions. Okay. So, for example, why it is both the direction? This one, this switch can carry the current from P to Q as well as Q to P, right, and it can block the voltage of only one polarity. Therefore, for this question option A is correct. Next one. Now, in this case, this switch cannot carry a current from P to Q. P to Q is not possible. Why? Because this diode is placed in a reverse direction, but this can carry the current from Q to P. Okay. Therefore, this device is just unipolar device. Unidirectional device. This can carry the current from Q to P only. So, we do not want that device. Next one, this particular device can carry the current only from P to Q. It cannot carry the current from Q to P. Therefore, these 2 options we can reject. Now, coming to this one, this is, it can carry the current in this direction. This can carry the current in this direction as well. Overall switch can block voltage of positive and negative. Therefore, for this switch also these characteristics are applicable. Okay. So, I can simply draw this one. unipolar and bidirectional. So, voltage of unipolar and current is of bidirectional. So, this is a V and this is a I. So, for this question, option A and option D, these two are the correct answers. Okay. Now, let us look into the next question. This question was asked in 2020 for 1 mark. A double pulse measurement for an inductively loaded circuit by the IGBT switch is carried out to evaluate the reverse recovery characteristics of the diode, represented approximately as piecewise linear plot of the current versus time at diode turn off. No need to worry about this lengthy statement. This complete data is just to scare the student. L par is the parasitic inductance due to the wiring of the circuit and is in series with the diode. Now, what we need to identify finally, the point on the plot indicate your choice by entering 1, 2, 3 or 4, at which the IGBT experiences the highest current stress. So, in this case, the diode, see, this is a diode reverse recovery characteristic. Of course, strictly speaking, it will not be exactly a straight line characteristics, just for simplification it is given as a straight line characteristics. Now, we just need to identify that the point where this IGBT express highest current stress. So, for example, this diode reverse recovery characteristics. So, originally we will measure for a diode, characteristics will be something like this, right, anode to cathode. So, whatever the negative current, that is a negative peak value of this current, this point, this negative current means the diode has to carry from anode to cathode. In other words, that current will flow through IGBT. Therefore, the point where IGBT experiences highest current stress, that is this instant, third instant. So, all these questions I can consider that the questions, basic questions on switch concept. So, with this basics of power semiconductor devices part 1 video I would like to conclude. Thank you. We will see the remaining questions in part 2.